Hi everybody. Today we're going to talk about the greenhouse effect. So what we have here is that visible light and short wavelength infrared light can enter the greenhouse. It then is going to warm up the items in the greenhouse. So that means some of the energy is transferred to the objects in the greenhouse. So the energy that comes off, that is reflected, has changed wavelength. And that makes it a longer wavelength infrared light. And that interacts differently with the glass. It doesn't just pass straight through. Some of it will bounce back. Here's an image showing the electromagnetic spectrum. All of these different types of wavelengths of energy come from the sun. And for the greenhouse effect, we're focusing right here on visible light and infrared radiation. So you can see that in general, visible light has a shorter wavelength. The distance between the crusts is smaller. But after it's interacted with things on our planet or within a greenhouse, it's going to change the wavelength and make it longer, which will affect how it then interacts with the layer of glass, if we're talking about a greenhouse, or gases, if we're talking about the greenhouse effect. These yellow dots represent a sunlight photon, which is going to be mostly visible light. When it strikes the planet, you'll see that it turns into infrared. No greenhouse gas concentration. You'll see that the infrared can just pass right back out again. But as we put in greenhouse gases, do you see some of these infrared ones are now changing direction and heading back down? So what that's showing is that the number of greenhouse gases is going to impact how these move. It's a little easier to see it if we do it with glass. Okay, so again, we got sunlight photons and they're changing into infrared photons. When I put in one pane of glass, you should start to see some of the infrared photons being affected and bouncing back down again. As I put in more layers of gas, you will see the temperature increasing because the infrared energy is getting trapped. And although some is passing out, more of it is getting trapped. Okay. So essentially, here we were looking at a greenhouse. Our planet acts like there's a greenhouse surrounding it, but it really is, it's this layer of gases, carbon dioxide, methane, water vapor, that will allow the visible light in, but does not easily let the infrared energy out. So see, when I have methane, it's not affected by visible light photons. It can go straight through. Carbon dioxide can go straight through. Water vapor can go straight through. All of these different gases are not impacted by the visible photons. But if we change them to infrared, look what's happening to the carbon dioxide. Do you see that? And so it's causing the infrared it's interacting with the infrared photon and changing the direction of it. Okay, and that's going to be essentially how the greenhouse effect works. Here we've got it with methane. Does the same thing. It's going to cause some of the energy to be absorbed by this type of molecule and cause that energy to bounce off in weird directions, including back towards our planet. Okay, water will do the same thing. And that's why methane, carbon dioxide, and water are considered the major greenhouse gases. Okay, nitrogen doesn't really get impacted, even though the majority of our atmosphere is nitrogen. It doesn't really get affected by the infrared photons. And same thing with oxygen, which makes up roughly 20% of our atmosphere. So when you learn about the greenhouse gases, it's the ones that are going to interact with these infrared photons are the ones that we are concerned about. And as this layer gets thicker, it means that less can pass out. more of the wavelengths of energy are striking the atoms here, and that causes them to bounce back down. You have less of the energy doing that and more of it doing this, okay? And trapping that energy in so that it continues to heat up our planet. All right, so here's an analogy. In a car, so the outside temperature is 80 degrees and the inside is 99. Oh my goodness. I bet we've all experienced that before, though, is that the inside can get really hot. And again, it's because the visible light goes in, it bounces around, and as it bounces around and transfers energy to the car itself, it becomes infrared. And that's going to increase the temperature. Here is yet another graphic to represent that. So here's the natural greenhouse effect. Okay, we got the greenhouse gases, solar radiation comes in, some is re-radiated, and some heat escapes. But as we thicken this layer, it means that more, it's like you put in extra panes of glass around a greenhouse. And so more and more energy is trapped. If you found this video helpful, please give it a thumbs up and click subscribe. Have a great day.